Welcome back with another episode of TryHackMe.com. We are doing DAST, and I'm Zahin Nazir. We're gonna start task 4. I already started my attack box and also the VM machine, which is over here. I will just cancel it out and go for a persistent session. Click it on start. Let's make it work. Okay, let's continue, guys. So this is task 4, scanning for vulnerabilities. Scanning for vulnerabilities, configuring a scan policy in ZAP. ZAP is the same Z-Attack proxy that we have installed, which is free and open source web application security scan. It is a powerful tool that penetration testers and security professionals can use to test the security of the web. When running DAST tool, it is crucial to customize what types of tests will be run against the application. The more you fit your scanning profile to your web application, the less time the scanner will spend sending payloads that are not relevant to your specific scenario. Since DAST tool will mainly be used in the white box setup, all the details of the underlying technologies used to support your application are known. Here are the details of the application we will be using throughout the room. We learned that DAST tool is usually used as a black box testing, not the white box testing. But in this case, since we set up everything, so we know the technologies. We know that the operating system is Linux. Web server is Apache 2.4. Programming language is PHP. No framework is used, just the vanilla version of the PHP database. There is no database at all. Okay. Let me get the URL of and let's run first spider, the same steps that we had done before, just to make sure that it is working fine. I'll do a start scan, and at the same time I will do a Ajax spider scan as well. Yeah, let's go with headless this time, and we'll be able to see all the information here. Okay, let's go back to our task here, which is 4. An example, our application does not use a database. If you run the default scanning profile, the scanner will try things like SQL injection. That would make no sense in this context. This would make your scan take longer, which might be okay with small apps like the one in this room, but the time increase will become noticeable when scanning more complex application. That is true. To create or modify scanning policies in ZAP, go to Analyze Scan Policy Manager. Analyze and Scan Policy Manager. Okay, it's still working. Analyze Scan Policy Manager. This is the default policy. Let's modify it, and now we have the same screen as shown in the tutorial here. In there, let's click add button to create a new one. Oh, we are creating a new one. Okay. Let's add new one here. Okay. From here, you can control the types of tests to be run as a part of your policy. For each category, you will have 2 parameters to configure: threshold and strength. This parameter controls the verbosity of each category. A lower threshold means ZAP will more likely to report a vulnerability based on little information. This would get you more findings at the risk of having ZAP report vulnerability that may not be present. False positive. A higher threshold will indicate ZAP to only report findings with a high degree of certainty. This will get you fewer results, but those are more likely confirmed. The risk of using higher threshold is that ZAP may not report some vulnerability that might actually be present. False positive. False negative. You can also set the threshold to off to disable a category. Okay, what they have done basically. So they disabled SQL and until XSLT injection. So let's do that. We'll go to injection and let's disable all of these. Do we have a disable option? Off. Can we do that for all of them? Off. No, one at a time. So let's continue with our list. This takes time, but yeah, okay. We disabled all SQL injection and XML type of vulnerability scanning. Okay. Since each application different, this pattern must be tuned accordingly. Think of this as a trial and error process to be improved over time. In the case of our application, since there's no database and in use nor any XML processing done, we can safely disable all of these related tasks as shown in the following image. We have done so as well. Make sure to also disable the cross-site scripting DOM-based tasks this time, as they take a lot of resources and are likely to slow down your scan for this room. So client-based cross-site scripting, we're gonna disable this one as well. Okay. Running our first scan. Now that we have a customized scanning policy, let's run a vulnerability scanning by going to Tools, Active Scan. Okay, first let's press OK. Fields of the policy must supply a policy name. Custom. Okay, so this is custom policy. And now we need to go to the tools and active scan here. We'll choose the custom policy and starting point is the same as this one. Select anything else that we need to change? No, anything else now. In the menu here, you can select a starting point from the previously spidered resources and our newly created scan policy. Let's use 10.10.58.6 colon 8082 as the starting point and check the resource box to ensure any page other than the starting point are scanned. Let's ignore the rest of the option for now and start scan. Okay. Let's do that. Okay. Let's see how many alerts we have. Oh, wow. We have 12 alerts. Cross-site referential forgery or request forgery tokens. Content one, directory browsing, missing anti-click jacking header, X power, see, information disclosure is there. Server X power by a lot of pages are giving this information. Good. Let us scan. Okay, you can also check the specific request and corresponding response that is ZAP used to detect the vulnerability. This is awesome. This allows you to review the findings to ensure they are all correct. Should you think any of them is a false positive, you can mark it as such by right-clicking the finding and selecting mark as false positive. Will disabling some of the test category help speed up the scanning? Yes, it is very obvious. Yeah. Okay, we're strict 6. There should be two high risk alerts in your scan uh, results. One is Path Traversal, and the name of the other one is okay. Uh, Cross-site scripting. This one reflected. Can we copy it? Okay. High risk. Yeah, we were able to do that. Okay, let's move on to task 5 quickly. Okay, authenticated scan. Yeah, this is really the butter of the DAST tool, right? Where every system is protected through some kind of authentication. So, dealing with logins. So far, we have run a successful scan and found some vulnerabilities in the target application. Our application, however, still has vulnerabilities to uncover. If we manually navigate to our application, we will see an administration console that can only be accessed with proper credentials. Since Zap now knows not about these credentials, it won't be able to check anything that requires authentication. We must teach Zap how to authenticate and ensure its session is active to solve this problem. To do so, we will record the authentication process into a Zest script so that this app can replicate the process during the scan. For now, think of a Zest script as a way to save and reproduce a series of requests. For this task, make sure to disable Zap HUD from the toolbar. Uh, some things will not work as expected if it is enabled. So you can find the button to do so at the end of the toolbar. Okay, do we have it? Okay, is it enabled? Now, yeah, it is disabled now. Recording authentication. To record authentication, we will click the record a new script button on the toolbar, which is this one. Let's set a title to our script and choose the type authentication. Okay. THM auth authentication, server side script, and then we'll choose the prefix, load on start. Okay. So this is the thing. THM auth type is not the session management, but authentication. Yeah. So prefix is this one, and load on start. Obviously, good. We have done this. Once we click the start recording button, every HTTP request that goes through Zap proxy will be recorded as a part of the script. Let's do so. Open a browser, click the open browser button on the toolbar, which is this one. Okay, navigate to this URL. I'll copy the URL. On the newly opened browser, we will log into the website manually on the Zap can record the process. So you can now use the following credentials to access the web application from the login page in the menu, which is no spiders. Okay, start recording first and then open the browser. Paste the link. No spiders. What happened? I'll copy this and paste here. Enter your inner cows mooing. What is that? Once you are correctly logged into the application, we will stop recording by clicking the record a new Zap script button. Again, feel free to close Zap browser as well. Some of the capture requests might not be necessary for authentication process and can be deleted. In this case, there are only requests that matter. Login. Okay, cow says. I'll put this default. Submit. Okay. So this is default, this is the cow. And let's close the browser. I closes the browser. I will click on it to stop the request. And here is the Zest script. As you can see, some capture request might not be necessary. So let's see if this is available within the scripts. Yeah, here it is. We have get, and then we have post on the login, and then the cow itself as well. Cow says.php. Okay. They are saying only this get requests are important. Okay. So let me delete this one. We don't need that. We need get, and we don't need all of these. Let me delete that. So we'll have only 3 of them. And we know that yani, in the login process, no JavaScript is being used. So we know that, right? Otherwise, we'll keep it there. Okay. So let's move forward. Okay, for each of the requests, Zav will check the status code and response lengths to see if they match. If they do, Zav will assume the login was successful. You can now test the recorded script by pressing run button on the script console. Okay, sure. So this is the run button. Yeah, so we are able to log in. Once you post, they'll say, okay, it is redirect. Redirect is going to cow say.php. This is what we're expecting. I think so. Yeah, cows. Okay. This should allow you to test if you recorded the process correctly by checking the responses to the request. Our application should respond to the post request to login.php with the redirection to cowsay.php. Okay. So what is the response? Here. This is the post request. So yeah, we have this 302, and then the location is cowsays.php. So we are good. Creating a context. Now that our authentication process is recorded, we need to tell Zap where to use it. This is done by creating a context, which is nothing but a way to define a group of URLs. Okay. Since this is simple application, the recorded authentication will apply to the entirety of it. We must therefore define a context that includes every single URL in the app so that we can link our Zest script to it. Note, depending on your target app, the recorded authentication might grant access to only part of the application. Think, for example, of an education platform where you have teachers and students. It would be expected that teachers and students each have access to different parts of the application based on their roles. For Zap to cover both sides of the application, we would need to record 2 authentication Zest script, one for student account and one for teacher, and attach them to 2 different contexts with the corresponding URLs. Okay, to create a new context, go to the Sites tab and right click the base URL of the target application on the Sites tab and select include in the context as new context. Okay, include in the context and new context. This will automatically create a regex that matches any page on the web application. There are many options you can configure under a context. For now, click on the authentication and link your DAST script by using script-based authentication. Okay. So, where is the context? Here is the context. Including the context. I'll put a new context here. All right. Then included in the context for authentication, let me include script-based authentication, and we already have a authentication script which is THMAuth. I'll just configure it here. Anything else we need to do? Be sure to click the load button to the right of the script name. Really? We need to do that? Yeah, it is loaded. Thanks for the tip. You can also configure authentication verification in this tab so that Zap can check whether it has a valid session or need to re-authenticate during the scans. But we will do this later in an easier way. Okay, check every response, and that's it. Okay, to do authentication scans, Zap will also need you to define at least one user in the user section. This won't be used at all in our case, as our DAST script embeds the user and password we will use. However, Zap needs a user to be defined, or it will just skip authentication altogether. Okay, so at least one user should be defined, otherwise it will skip the authentication, right? The username is now spiders, and it should be enabled. So let me copy paste, add. I have done so, and it is enabled. Matter of fact is why the ID is not visible. Wait a moment. Yeah, it's 238 for us. Okay. Once this is done, press OK, and you should see all the side resources are now marked with the target icon, meaning they are now part of the defined context. Okay. So this is our context. Let me copy it. Okay, yeah, so they are part of the context, right? Now they are saying respattering the application. Now that we have a context set with our authentication script, let's run this spider, but setting the context, correct context and use and user we created. Okay, so let's run another spider. Either we can do that from here. Do we have any button to do that? Yeah, we have spider. Okay, and this is the user we will gonna use. All right, start scan. Okay, it was very quick, man. It was very quick. Okay. This time ZapTool should be able to find any resources that require authentication and were not detected before. Let's hit the start scan button and see what we get. If you want to see if any new resources were discovered during a spidering session, you can always check the added nodes. Okay, so for me the log out is added node. The cow one was already there. Where is the cow? I don't see the cow. Yeah, cow is here. Okay, and these were the added nodes. For them there are a lot of added nodes, but for me these are already there. Address logout is a new one for us. Zap has found a couple of additional PHP scripts. One of such script is in charge of logging a user out. Might pose a problem if Zap tries to access it. It will log out its session. avoiding logouts. To prevent Zap from the logging out itself, we will right-click the logout PHP script in the side tab and exclude the script from our context. Okay, let's do that. We have log out here. So exclude from the context. Okay, so exclusion from the context is added. Click on OK. We are good to go. And you can see it is excluded. There is no icon for the context. Now Zap will avoid interacting with logout script during spidering or scanning. Note that depending on the application, it might be desirable to exclude some other script as well. Knowing how the application works is extremely important to get the most out of the scanning process. That is very true. In addition to preventing direct logouts, we can specify indicators for Zap to identify if its session is still active or not. Repeat the login script if necessary. This is easily done by selecting parts of response that only appear when you are logged in or logged out. For example, we know that cow.say.php can only be accessed if you have successfully logged in. So it might have good indicators we can use for Zap. Let's select cow.say.php from the side tab and select the text that correspond to the logout link. Okay. From the side tab and select the text. And then we're gonna authentication login indicator. Okay. So where is the cow? Say, here is the get cow say. I double click on it. I'm gonna check the response here. So this is the get message, right? Okay. So get will give us, this is the top navigation, and this is what we are looking for. Okay. And then right click as flag as context, authentication login indicator. Right click, flag as context, and this is the logged in indicator. Authentication, and here is the regex pattern used to identify the login message, which is this one. Check every response. Okay, we are good. Some side tabs and select the text that correspond to the logout. Okay, right click and select text and choose flag as context, your context name, authentication login indicator. We have done so as well. From now on, Zap will search for logout link on each response. If it isn't present, it will assume its session needs to be renewed and log back into the application using Zest script we recorded. You can also do the same to select a logged out indicator. Since we know the login link should only be visible if you are logged out, we can use it for this purpose for following a similar procedure. Let's grab the links HTML from the aboutme.php script in the sites tab. Okay, which is this one, guys. Okay, right click, select text, choose flag as, and your context authentication logged out. Okay, so this is about me. Here we go. There will be a log in. I'm trying to find it. Where is the yeah, here is the link. It is still log out, man. We are looking for log in, right? Wait a moment. We have logged out as well. No spider. Why it is like this, guys? I get all the responses as, yeah, we have one with view.php with login. Wait a moment. So they're saying about me. Uh, so about me was having log out. We find one which has. It may be possible that Zap has cached the authentication response for about me.php. In that case, you will need to resend a request via the built-in browsers to the URL to get the correct pattern. Okay. How are we gonna do that? Wait a moment. Resend the request. Okay. Send. So in this case, yeah, we have login here. So I'm gonna go to about, since it is not logged in. So I'm gonna select it now and flag contacts. Then authentication logged out indicator. Okay. So this is regex pattern used to identify logged out message. I will press OK. They're almost done. Okay. Note, it may be possible that Zab has cache. We have done this already. Now that Zab has patterns to identify if it is logged in correctly, we need to choose a verification strategies to tell it how to use the configured patterns correctly. Depending on the website you are checking, you will want to use different strategies and tune them to suit the target application. In this case, we will use the pool the specified URL strategy. Tell it to pull the about me.php resource average 60 request to check if the logged in login pattern. To do this, double click the context and change the following settings. Okay, so we are on the authentication. Then we have verification strategy, pull the specified URL, and then URL to pull for verification is about me. Okay, and then press OK. Let's do that. So again, sorry, about me, session properties, from where we get this, yeah, guys, from context, right? So how I can see the whole context. Just a moment. Here is the context itself. I'll double click on it. Okay. And then we're gonna go with pool specifier the URL. Let me select the actual URL, which is about me here. Select forecast data, if any. Do we need to change anything else? No, we just select, click OK. Because 60 was already selected, right? Yeah, this one. Let me check this one again. Double click on the context. Yeah, pool frequency 60 after every 60 request. Okay, we are good. We are good. Rescanning the application one last time. We are finally set up to run a new scan on the application, knowing that it will now cover the areas of the application that requires authentication. Let's go to the tools, active scan, and select the contacts and the user we created. Tools, active scan, policy is this one, context. I will select this context. Okay. Why the context is not available. Okay, let's do that. Okay, yeah, selected. No spider as well, and start the scan. Oh, wow. It is doing a lot of requests. It's sending a lot of requests, and we have 22 alerts already. And here is our history. And here is our active scan, which is 42% done. Let's see what else we need to do. If you follow these steps correctly, I will now find a new high-risk vulnerability. Be sure to take note of it to respond the questions at the end of the task. Sure, we will do that. Which type of script was used to record the authentication process to our site in this app? DAST script. DAST script. Okay. What additional high-risk vulnerability was found on the site after running the authenticated scan? Okay. We'll go to alerts. Oh, remote OS command injection. Oh, this is big one, right? That means you can run the commands remotely on your server. Awesome. So thank you guys for joining me on this journey. We have completed task 5 until now. Once we'll come back, we'll do the task 6, 7, and 8 because the video is already 6 minutes past. So thank you guys for all the love and support on this channel. If you haven't subscribed, please subscribe and give a big thumbs up to this video, share it with others. We are building Desi community around this channel, so we're targeting 1,000 users by August 2024. Thank you very much for joining me, and I will see you in the next video. Bye.